Roots. Oh, I guess we should say square roots. Except before we do square roots, take out another blank piece of paper and write squares on it. Seems to me I thought we did this before, didn't we? Perfect. Okay. Let's do this as quickly as humanly possible here. Okay, this little thing, this little number, when you have a little number up there, that thing is called an exponent, or it is also called a power. Today, you can have any number up there you like, but today we're only talking about when it's a 2 up there, which we call a square. You say this number as, this whole thing is called 5 squared. Okay, that's how you say that. When you see this, it's 5 squared. This would be 7 squared, 8 squared, whatever squared. The 5, the 2 is the exponent or the power. The 5 is what's called the base number. And when you see such a thing as this, Bella, did you do this as 5th grade? How about that?
Yeah, I think we did.
Okay, when you see this square thing, okay, the exponent tells you how many bases get, now here's the big word, multiply together. Give you a chance to write that then. We will talk at length about that. The exponent tells you how many bases get multiplied together. So, if you see 5 squared, that means you have 2 5s multiplied. And it's not, the most common mistake people make is they tell me it's 10. No, that's 5 plus 5. This is 5 times 5, which is 25. Okay? This is not 5 times 2, it's 5 squared, or 5 to the 2nd power. Same thing. 7 to the 2nd power is not 14, it's 7 times 7, which is 49. 8 to the 2nd power is not 16, it's 8 times 8, which is 64. Okay? And these, in the math world, you'll learn to recognize these. These are kind of special numbers in our world. You know, and you can go through the whole list of them. 1 squared, 2 squared, 3 squared, 4 squared, you know, they're special numbers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Those are all squares. They're all the numbers squared. So if you're given a problem like this, if you're given 3 squared plus 4 squared, by the way, in order of operations, you always do the square part first. What is 3 times 3? It is 9. What is 4 times 4? And then what is 9 plus 16? 25. That would be the answer to that problem. Okay. Boom. Now take out that blank piece of paper where we just talked about. Under roots. Actually, it's under square roots. roots are really like the opposite of exponents. Okay, and a lot of times there's a number up here in this little thing here. This is not a division problem, but this little squiggly line here, it makes it not a division problem. Okay, well, this number, when there is no number there, see, look at there, do you see a number there? No, there's no number there. When there's no number there, it's an assumed 2. Okay, and that 2 means it is a square root. If, and we won't get to this till a little bit later, if there was a 3 there, that would mean it's the third root of, or a cubed root. If it was a 4, it would be the fourth root. But when there is no number there, we assume it's a square root. Okay? And what square roots are, they're the opposite of exponents. In other words, this. You need to answer this question. When it's a square root, and you would say this, what is the square root of 36? The square root is what number times itself equals, and this number right here is called the radicand, equals the radicand. And this little thing right here, guess what that thing's called? If you were a surfer in California, you would like this because it's called the radical sign. It's radical, dude. The number that you don't see there, that isn't there, if there was one there, that's called the index number. And in this case, there's no number there, so we call it a square root. So when you see the square root of 36, you are looking for what number times itself gives you 36. What number times itself gives you 36? 6. So that is the one and only answer for right now of what's the square root of 36. Okay, and remember when we just got done talking about the squares, there are only certain numbers that work out nicely for us in this whole square root world. For example, if I asked you to tell me what the square root of 15 is, you would tell me that the square root of 15 is, Mia? Gabran? No, 5 times 5 is 25. The square root of 15 is, Brooke? Well, there is one. But it's in the mathematical world, the answer to that is it is an irrational number. 7.5, let's try. 7.5 times 7.5 to me gives 37, 35, 3, 49, 52, 5, 2, 1, 6. I get 56.25 when I take 7.5 times 7.5. Okay? There are only certain ones that work, and those are called the perfect. It's the ones that are the perfect squares. The only numbers that work out nicely were the ones we just talked about. You can have a square root of 1, because there is a number times itself that gives you 1, which is? You can have, what would be the next perfect square? 2 times 2 is 4. So the square root of 4 works out nicely. It is 2. What would be the next perfect one? 3 times 3, which is the square root of 9. That gives you a 3. Next perfect one? Square root of 16 is 4. Next perfect one?
25.
Square root of 25. Now let's stop here and just take a thought here. Since the square root of 15 falls between here, square root of 15 is between 9 and 16, that would mean the real world answer for that has to fall between 3 and 4. And it's awful close to 16, so it's going to be, if you were guessing what the square root of 15 is, if I were going to give you the square root of $15, you would get almost, but not quite, $4. Okay, and if you had a calculator, you could put the square root of 15 in there, and it would probably give you 3 point, I don't know, maybe 8 something, blah, 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 blah. As a matter of fact, we have a calculator. Let's make, ooh, that's not that one. We have a calculator. Let's see if I can pull it up here. If I want to know what the square root of 15 is, I go 15 and I go square root. Where is it? It's here somewhere. There it is. 3.8379833462074115. Okay, it took a picture. Okay. And again, the reason why these ones that don't work out, we call them irrational numbers, is because in the real world, there is no exact square root of 15. This calculator stopped here at 7, but in the real world, that decimal goes on forever and it never ends. You can never get the complete exact square root of 15. Okay? And pi is another one of those irrational numbers. Okay, it goes on forever. It's not a fraction. It's not a perfect square of anything or whatever, a square. Okay? These are the only, give me another one. What would be another square root, a perfect square that would work out? We've already got square root of 1, square root of 4, square root of 9, square root of 16, square root of 25. Another one would be what, Alex?
36.
Right, the square root of 36 is 6. Another one that would work out. The square root of Landon?
49.
49, that would be 7. The square root of Maggie? Oh, we're going in order. I like that. But you could give me something. The square root of 64 would have to be 8. How about another one? Another one that would work out. Sammy?
144.
Ooh, look at her. She's giving me the one. What is the square root of 144? It is 12. Okay. Those are very few of them in our world are going to work out. So the book will probably give you all these nice ones because they're pretty nice to you to start off with. But if you do see something like the square root of 70, even though it doesn't work out, you should be able to tell me what it's close to. What times what gives you close to 70? And we already know the perfect squares, so if you think about the perfect squares, what was the highest one we had? We had square root of 64 was 8. The next one is the square root of 81, which is 9. Where would the square root of 70 fall? Somewhere in between here. So the square root of 70, if I gave you the square root of $70, how much money would you about have? Somewhere between $8 and $9. Okay. Even though it's what we call irrational, doesn't make sense. Okay, that's where we get there. Oh look, they get a little mean with you. Yeah, how about this? Check this out. They might ask you a question like this. What is the square root of m squared? And again, you just have to ask. Yes, what can I help you? You just have to ask yourself, what number times itself gives you m squared? Anybody? Oh, maybe this will make sense to you. What if I had the, I don't know why they ask you this question, but let's do this. What if it was this? What if it was 5 squared? What is 5 squared? So what is the square root of 25? 5. So if it's m squared, making the connection there, 5 squared is 25 gives you 5. Whatever this thing squared is gives you 5. So this is just m. I don't know, it's one in the book. I don't know why they gave it to you, but it's interesting. I don't know. I gotta plead ignorance on